Okay, next one then, we'll do the probability that the length of a leaf is less than 8. We never actually said units anywhere, this is all in centimetres, okay? Probability, the length of a leaf is less than 8. Can anybody tell me my phi statement? Or what I write down here, my phi notation?
Minus 10.
8 minus 10, that's x minus mu
Divided by 10.
divided by sigma. Yep, that's it. Can anybody tell me what that is?
Minus 2.
Phi of minus 2/3. We need to change that to a decimal. Phi of minus 0.667. Look in your tables, find phi of minus 0.667.
Here is
Is it the same, but you just do 1 minus?
Yeah, you're thinking the right thing. You will not find phi of a negative number in the tables. So, just to explain the reasoning behind what some people actually said, which is correct. If you do a drawing a minute,
Can you
Okay. what we have got here is we have a distribution with a mean of 10. We are interested at the moment in the probability it's less than 8. This is our L variable. That is that. Now we have mapped that onto the Z distribution with a mean of 0, and what we said we're interested in Z terms of minus 0.667. We are interested in that area there, and those areas are the same as each other. If you look in the tables down the left hand column, there are no negative numbers there, so somebody was correct. What you've got to deal with is, by the symmetry of it, what we are going to deal with, if I change colour a minute, is what is over here, 0.667. That area will be the same as this area, will be the same as that area, because it is purely symmetrical. So instead we will use 0.667 from the tables, which we actually have already used. That will give us, changing colours again, this area here, which is everything we don't want. So we have to do a 1 minus. So what we will be doing here is that will turn into 1 minus phi of 0.667. And we've already worked out 5.667 in the last question, so I'm just going to jump down here. Phi of 0.667 we said was 0.7477. So we should get here, according to me, 0.2523.
Yeah.
Okay? What I want to do is sort of just write down what we did here for you in what I'll call a red box rule. And that is, if you have phi of negative z, then you do 1 minus phi of positive z. That is how you deal with that. So that is our red box rule. First one of today, really. So if you have to fight a negative number, you do 1 minus phi of the number without a negative sign there instead. As we go through, we'll see if there's any other sort of little tricks we need to learn. Yeah, there you go. Okay. Okay, the next one, we're still dealing with the same leaves. We finished that example. We will move on now. And I'll just write down a distribution again. We had L was normal 10, 3 squared. 3 squared is the same as 9. Doesn't matter which way you write it down. So what we're going to have now is the probability that L is greater than 11. Why don't we like that question?
Because it's bigger.
Because it's a greater than. What do we do?
1 minus.
Yes, let's do a 1 minus. It's less than or less than or equal. Doesn't matter. Billy principle.
Can you use that after I've got on?
I don't know. Might do.
Legacy.
It's on video now forever. The Billy principle. Okay. So basically, you rewrite greater than as a 1 minus less than. If you want that as a red box. Okay. These don't go on the main YouTube channel. These go to the private ones, the recording and lesson ones. Okay.
Wikipedia page where people start reading it.
No, but what will happen is it will become common slang between all of these maths teachers, and
That's
children
fine.
will be hearing
Could well be.
go to school.
Billy.
Right, so finishing this example, can you finish this one off yourself from there?
Yeah.
See if you get the same number I'm going to get. For those watching on video, there we go.